Everyone, I hope you're doing well. This is the lecture third from Stochiometry. Last time we have done the balancing equation. Today we are going to talk about the molecular formula and empirical formula. Okay, so this is the most important thing in this chapter. So first we are going to define what is molecular formula. So it is talking about, it represents the actual number of atoms present in one molecule of compound. So suppose we have a molecule of glucose, suppose, which is C6H12O6, and you can see here carbon is 6, hydrogen is 12 and oxygen is 6. So this is the actual number of atom in this molecular formula. So this is called molecular formula. Number of carbon is 6, number of hydrogen is 12 and number of oxygen is 6 as well. What is empirical formula? So it is the simplest whole number ratio. Make sense? Means we can generate the empirical formula from molecular formula. Look at here. Suppose this is my molecular formula, which is C6H12O6, and here the smallest number is 6. So you can divide 6 by all these 3 atoms, so you will get this one. Clear? C, carbon is 6, so 6 divided by 6 is 1. Hydrogen is 12, 12 divided by 6 is 2, and this is 1 as well. So this is the simplest ratio. Simplest ratio. RATIO, sorry. If you look at this C2H6, the small number is 2. So if you divide with the 2 with both atoms, so you will get CH3. So this is the empirical formula. Okay, and this is my molecular formula. So empirical formula is the simplest whole number ratio of molecular formula. Makes sense? So here we have some relationship. Molecular formula is equal to N into empirical formula. And what is N? N is a molecular formula weight. And what is empirical formula weight? This is empirical formula weight. Look at here. Suppose I am saying we have C2H6 and this is CH3. So this is my empirical formula and this is my molecular formula. What is molecular formula weight here? So you can see 12 into 2 plus 6 into 1. So what is this? 24 plus 6, 30. So this 30 is my molecular formula weight. And this empirical formula is 12 plus 3 into 1, which is 15. So 15 is my empirical formula weight. Makes sense? Like this. And if you define the N value for this, so N is equal to molecular formula weight divided by empirical formula weight. So 30 divided by 15, which is 2. Clear? So let's discuss this question. It is talking about a compound has molecular formula, molecular weight is 90. Its empirical formula is CHO2. And what is the molecular formula? We all knew molecular formula is equal to N into empirical formula. So what is N? N is equal to molecular weight, molecular formula weight divided by empirical formula weight. So molecular formula weight is what? Molecular weight, which is my 90. So 90. This is my empirical formula, and what is empirical formula weight? You can see 12 plus 1 plus 16 into 2, which is 32. How much it should be? So 13 plus 32, 45. So this is 45. So N value is here 2. Clear? N value is it here 2, and we all knew molecular formula is N into empirical formula. So molecular formula is equal to 2 into empirical formula is CHO2. So if you solve this, it will be C2H2O4. Clear? This is my molecular formula. C2H2O4. Clear? Quite easy. So a compound has a vapor density 45 and its empirical formula is CH2O. What is the molecular formula? So here we have a formula between vapor density and molecular weight, which is 2 into vapor density. So we can find out the molecular weight for here, for this. So 2 into vapor density, how much? 45. So molecular weight will be 90. And we all knew molecular formula is equal to N into empirical formula. And N is what? Molecular formula weight is equal to empirical formula weight. So molecular weight is 90. Empirical formula weight is how much? We can find out CH2O. So 12 plus 2 into 1 plus 16. How much? So it is 14 and 16. So 30. So 90 divided by 30, which is 3. So N value we have 3. N value we have 3, and we all knew molecular formula is equal to N into empirical formula. So we will multiply with N with the empirical formula. So molecular formula is equal to N value we have 3. Empirical formula is CH2O. So answer will be C3H6O3. Clear? This is my molecular formula. Easy. Here only the task is what? Molecular weight, which is 2 into vapor density, because this time we don't have molecular weight, we have vapor density. So there is another type of question. We have a compound which is composed of carbon, hydrogen and oxygen, which is the percentage given here. 40% is 6.7% and 53.3%, and its molecular weight is 60. Find out the molecular formula. We have to find out molecular formula. So whenever you have such a type of question, always generate this table. The first element, percentage value, atomic weight, and then ratio of percentage with atomic weight, and then the simplest ratio. Look at here. Element we have carbon, hydrogen, oxygen. Carbon percent is 40. Hydrogen percent is 6.7. And oxygen is 53.3%. So what is atomic weight of carbon? 12. What is atomic weight of hydrogen? 1. And what is the atomic weight of oxygen? 16. And what is the percent of atomic weight? So percent is 40, atomic weight is 12. So 40 divided by 12. 6.7 divided by 1. And 53.3 divided by 16. So if you solve this 140 divided by 12, how much it should be? I think it's 3.33 somewhere. You can calculate. Suppose this is approx to be 3.33. I am just assuming, suppose the value is 3.33. And this is 6.7. And I think this is also 3.33. So what is simplest ratio? We have to find out its simplest ratio. So look at all these values: 3.33, 6.7 and 3.33. Which is the lowest one? 3.33. So we will divide the lowest number with this ratio. So for here it will be what? 3.33 divided by 3.33, which is 1. For hydrogen, 6.7 divided by 3.33, we can assume as 2, approx 2. And again 3.33 divided by 3.33. So how much? 1. Clear? So my empirical formula ratio is what? CH2O. This is my empirical formula. Makes sense? Why? Because empirical formula is what? Simplest ratio of atom, and we got the simplest ratio. And but the question is talking about molecular formula. We all knew molecular formula is what? N into empirical formula. And what is N? N is a molecular formula weight divided by empirical formula weight. Molecular formula weight is given, which is 60. Empirical formula we can figure out 12 plus 2 into 1 plus 16. So this is 14 plus 16. 30. So 60 divided by 30, which is 2. And now it's quite simple. We have the empirical formula, which is CH2O. So molecular formula is what? 2 into CH2O. So answer will be C2H4O2. C2H4O2. Easy. Clear? Okay, now we have this question: combustion analysis of a sample compound containing only carbon and hydrogen. Determine there was 18 gram of carbon, 1 gram of hydrogen in the sample. What is the empirical formula? Again, we can use two elements here, carbon and hydrogen. This time we have the weight is given 18 gram. We have carbon and 1 gram here hydrogen. So this is 18 gram weight, 18, and this is 1. So what we have to do now? Weight upon atomic weight, the ratio one. So weight ratio upon atomic weight. So weight is 18, atomic weight is 12, and weight is 1, atomic weight also 1. So once you solve this, you can say this is 2 9 ja 18, this is 6, and then 3, and this is 2. So this is 3 by 2 and this is 1. So, but again, this is a fractional value 3 by 2, and how we can eliminate 3 by 2? So look at this is 3 by 2, the ratio, and this is 1. So we can multiply by 2 both sides, then we can remove this fraction. So if you multiply by 2, so this 2 cancel out. So you have 3 and here 2, this is 3 and this is 2. So carbon is 3. The simplest ratio of carbon is 3 and hydrogen is 2. So it will be C3H2. Clear? This is my empirical formula, which is C3H2 is option B. Clear? Simple. And suppose you have to find out that it's a molecular formula, but we don't have molecular formula weight. If molecular formula weight is given, then we can figure out molecular formula quite easily. It's just N into empirical formula. Now the next question. Given that a certain compound empirical formula is NO2, its molar mass is 92, find out the molecular formula. So these questions are given in a very good practice material. So look at here, molecular formula is equal to N into empirical formula. And what is N? N is equal to molecular formula weight divided by empirical formula weight. So molecular formula weight is given, which is 92. Molar mass is 92. So 92 divided by empirical formula is given NO2. So we can figure out its empirical formula weight. So nitrogen is 14 plus 16 into 2, 32. So how much? 4 plus 2, 6, and 3, 1, 4, 46. So 46 is my empirical formula weight, and this is 2. So N value we got 2. And now we can keep here N value here 2. Empirical formula was NO2. So answer should be what? N2O4. This is N2O4. So N2O4 is option A. Makes sense? Simple. So we can find out first N value. N is what? Molecular formula weight divided by empirical formula weight. Molecular formula weight was given 92. Empirical formula we can calculate from this empirical formula. So once you have N value, then you have to keep this N value in this equation. Molecular formula is equal to N into empirical formula. N value we got 2, empirical formula given, so just multiply. Next, a sample of chromium oxide is 52% chromium by weight. What is the empirical formula of the oxide? So we all knew, if you're talking about chromium oxide, then there is a 2 element, chromium and oxygen. So we can write down here chromium and oxygen. And now if you look at the table, the percentage means what? Mass percent or weight, whatever. So mass percent is given, 52% is chromium here. So if chromium is my 52%, what is the remaining percent of oxygen? 100 minus 52. So which is 48%. Clear? This is mass. Next what? Atomic weight. So chromium atomic weight is 52. You can see the table, periodic table, and oxygen atomic weight is 16. Clear? And now we are going to talk about the ratio, mass divided by atomic weight. So mass divided by atomic weight, so 1. Mass divided by atomic weight, 48 divided by 16, which is 3. So this is the whole number. So this is the already a simplest ratio. So chromium is 1, oxygen is 3. So CrO3 is my empirical formula. Simple. Let's talk about the very last question. The empirical formula of a compound is found to be CO3. What is the molecular formula if the molar mass of the compound is 180? Simple. We all knew molecular formula is equal to N into empirical formula. Clear? Empirical formula is given, which is CO3. So let's find out the empirical formula weight. So 12 plus 48. So how much? 60. And this is 180. So find out N value. N is what? Molecular formula weight divided by empirical formula weight. So molecular formula weight is what? 180. And we got the empirical formula weight, which is 60. So N value how much? 3. So N value we got 3. And now you have to multiply with 3 the empirical formula, which is CO3. So once you multiply CO3 with 3, so it will be C3O9. C3O9. So this is my molecular formula. Simple. I think this is all about the empirical and molecular formula. In the next session, we will discuss percentage composition, limiting reagents. Okay. So thank you so much for watching this. This is the molecular formula and empirical with questions as well. So just watch this, write down all these points in the notes and revise it every day. Yeah, just alternate day even you can revise. So this is all about the stochiometry. This is lecture number 3. In the next session we will discuss the rest of the thing. Thank you so much.